Hello friends, welcome to my channel Physics with Rakshi. From this video, I'm going to start one book on loop quantum gravity, that is loop quantum gravity for everyone, which was written by two founders of loop quantum gravity, that is Rodolfo Gambini and Jorge Pullin. In this book, they explained loop quantum gravity for everyone, whether you are physicist, whether you are amateur, whether you want to know just loop quantum gravity at glance, you should read this book. And that is why from this video, I will start to explain loop quantum gravity according to this book. As I worked in loop quantum gravity, I will also apply my experience of research on loop quantum gravity to comprehend this book and concept of loop quantum gravity. Let us start. In this video, I will just introduce what will this book will describe. So as I explained many times, loop quantum gravity is one of the supposed candidate or one of the contender of quantum gravity. What is quantum gravity? A theory that could unify general theory of relativity with quantum physics successfully is known as quantum theory of gravity. Still, this theory is under progress, and that is why it is incomplete. And there are many proposals for quantum gravity of quantum theory of gravity, like Regge calculus, causal sets, causal dynamic triangulation, string theory, loop quantum gravity, twisted theory, etc. Among all these proposals, string theory and loop quantum gravity are supposed candidates, in which string theory originated from quantum field theory, while loop quantum gravity was originated from general theory of relativity. And that is why string theory is background dependent and loop quantum gravity is background independent. And that is why one of the founder of loop quantum gravity, Carlo Rovelli, once told that in loop quantum gravity, loops are one-dimensional objects that forming space, while in string theory, strings are one-dimensional objects that moving in space. So this is the fundamental and most important difference between these two proposals or supposed candidate of quantum theory of gravity. So there are many theories which are required to understand quantum theory of gravity. First branch is classical mechanics, in which we study all continuous kind of phenomena without any kind of strangeness, like uh, uncertainty, superposition, which are introduced in quantum mechanics. Newtonian mechanics and many other branches falls in this category. Second one is Newton's gravity, which only explains the magnitude of gravitational force, but failed to explain the mechanism of gravitational interaction. Next branch is quantum mechanics, in which all classical physical quantities are quantized, like energy, momentum, etc. Another is electromagnetism, in which electricity, magnetism, and optics are unified in one framework, and it was given by Maxwell majorly. Next branch is special theory of relativity, which was given by Albert Einstein, as we all know. Another branch is general theory of relativity. We know that special theory of relativity considers invariance, while general theory of relativity considers covariance. In special theory of relativity, there are some axioms or hypotheses like, or fundamental principles like speed of light is constant and all known laws of physics are invariant under uh, continuous transformation and under inertial frames, reference of frames. In general theory of relativity, we consider accelerative reference of frame or non-inertial reference of frame, which explains gravity completely as deformation of space-time that I explained in my previous video of my YouTube channel. Next branch is quantum field theory, which unifies quantum mechanics, electromagnetism, and special theory of relativity, which also study three fundamental interactions, that is strong nuclear force, weak nuclear force, and electromagnetic force. Using quantum field theory, you can quantize these three fundamental interactions. But as gravity is deformation of space-time, it couldn't be quantized under quantum field theory framework. Another is quantum field theory in curved space-time, which was studied by many physicists like Stephen Hawking and many other general relativists. And by unifying all these branches, that is classical mechanics, Newton's gravity, special and general theory of relativity, electromagnetism, quantum mechanics, quantum field theory in curved space-time, we can have quantum theory of gravity. It means that all the proposals, whether it is string theory, loop quantum gravity, Regge calculus, twistor theory, causal sets, causal dynamic triangulation, Einstein's quantum gravity, require unification of all branches. It means students have to study all these branches. Thereafter, they will be ready to understand what is quantum gravity actually. So this is how complex quantum gravity is. So what is loop quantum gravity? In one sentence, loop quantum gravity means unification, and it considers two important concepts. Background independence, it means in loop quantum gravity, priori no geometry, no coordinate system or no space-time are required. It will create space-time, and that is why it is background independent. Another one is diffeomorphism invariance, which is kind of symmetry that we will study. So first question is why quantum theory of gravity is necessary. There are some phenomena in physics like singularity of Big Bang, black hole, where quantum effect as well as gravity, both concepts are required. And to understand these objects and phenomena, a theory requires which can unify quantum field theory with general theory of relativity at Planck scale. Another thing is, we know that quantum mechanics is required to understand, as I told, strong nuclear force, weak nuclear force, and electromagnetic interactions, as these three forces are renormalizable in quantum mechanics. Another thing is quantum mechanics is very strange. We require to study granularity, superposition, uncertainty, measurement problem to understand quantum mechanics completely. And that is why it is strange. Thus, it is difficult to unify with general theory of relativity. As in quantum mechanics, three fundamental interactions like electromagnetic force, strong nuclear force, and weak nuclear force are interactions or force, while in general theory of relativity, gravitational or gravity is deformation of space-time. It is created because of deformation of space-time. Thus, it is very difficult to incorporate both theory or to unify quantum physics with general theory of relativity. Another thing is quantum mechanics studies microscopic phenomena or microscopic objects, while gravity or general theory of relativity studies macroscopic phenomena or macroscopic object like astrophysics, astronomy, etc. So in this book, we will study various topics which are required to understand quantum gravity. In this first video, I introduced this book and fundamental concepts of quantum gravity and why quantum gravity is studied in physics. So I covered chapter 1, that is introduction of book Quantum Gravity for Everyone. Next chapter is gravity, in which we will study how general theory of relativity treats gravitational interaction, why gravity is deformation of space-time, why it is difficult to understand gravity using quantum field theory. Third one is quantum theory, which studies rest of the fundamental interactions, as I told. Next, I will cover quantum gravity and its fundamental concept at glance, as this book explains quantum gravity for everyone. So it is my duty to emphasize that quantum gravity is not that simple. There are numerous books which are having thousands of pages with mathematics, and still you cannot understand quantum gravity completely. But for popular audience, for physicists, for amateurs who just want to understand quantum gravity at glance, in simple word, these lectures are enough. In fifth video, we will see application of quantum gravity to understand black holes. In chapter 6, we will see second application of quantum gravity in cosmology, which is also known as quantum cosmology, LQC. In chapter 7, we will see further developments in quantum gravity, that is spin form, which is also known as covariant quantum gravity. In chapter 8, we will see possible observational consequences through which we can observe quantum gravity using current framework or current technological regime. And in chapter 9, we will see some important conclusions which was given by authors of this book, that is Quantum Gravity for Everyone. Thanks for listening and watching. If you like my video, please share and subscribe my YouTube channel. Hello friends, welcome to my channel Physics with Rakshit. In the present video, we will see second chapter of the book Quantum Gravity for Everyone, that is gravitation. In the first video, we saw fundamental concept of this book and introduction of this book, which was authored by Rodolfo Gambini and Jorge Pullin. In this video, first of all, I will explain history of unification of forces in physics. Thereafter, we will see general theory of relativity that explain gravitation. Let us start. We know that in 19th century, Maxwell gave his 4 famous equations that could unify electricity with magnetism and predict that what is electromagnetic wave. And thereafter, physicists found that light is nothing but electromagnetic wave, and so optics was merged with electricity and magnetism, which is collectively known as electromagnetic theory. Here I have shown electromagnetic wave in which electric and magnetic field are perpendicular to each other and perpendicular to the direction of propagation. Thereafter, physicists found quantum mechanics in the beginning of 19th century. Thereafter, Einstein came up with special theory of relativity, and by unification of special theory of relativity with quantum physics, physicists found quantum field theory. And thereafter, physicists attempted to quantize electromagnetic theory, and physicists got first quantum field theory, which is known as quantum electrodynamics. We can see many implications of electromagnetic theory or electromagnetic interaction in day-to-day life. There are many gadgets which use fundamental concept and principles of electromagnetic interactions, whose mediator particle is photon. In 1960s, physicists find more two interactions at subconstituent level. Physicists also found that atom has subconstituent particle like neutron and proton, which has more subconstituents like quarks. And strong nuclear force for interaction is responsible for binding nucleus together by balancing electromagnetic repulsion, which was created by protons, various protons. Weak nuclear interaction is created because of particle decays and which is manifested at astrophysical levels, which is also manifested in nuclear phenomena. These two forces are not visible for us in day-to-day life and for our naked eye, but there are several implications of these two forces in physics at conceptual level. Quantization of strong nuclear force is known as quantum chromodynamics, and quantization of weak nuclear force is known as quantum flavor dynamics. In 1950s and 60s, physicists attempted to unify weak nuclear force with electromagnetic interaction, which is known as electroweak theory, which was successful theory. And thereafter, physicists attempted to unify strong nuclear force with weak nuclear force and electromagnetic interaction, which is known as grand unified theory. I will explain each new term in my YouTube channel in separate videos. But here, whatever I have been explaining, which is only necessary for understanding gravitation. But it requires more time to explain all these concepts mathematically that I will cover in separate videos. In quantum field theory, there is a one theory which is known as Yang-Mills theory. It is a class of quantum field theory in which there are several electric and magnetic fields which are interacting with each other, and it explains grand unified theory successfully. Yang-Mills theory is also fundamental theory to understand mathematical framework of loop quantum gravity, and that is why I have introduced Yang-Mills theory here. Let us see some fundamental concept of gravitation according to this chapter. We know that in 17th century, Newton came up with his universal law of gravitation, according to which gravity is proportional to the product of masses and inversely proportional to the squared distance between them. Newton was successful in explaining solar system, but not completely. There are some flaws, like according to Newton's gravitational theory, gravity propagates instantaneously, spontaneously, which is impossible according to special theory of relativity. And it is Einstein who found this flaw. In 1905, Einstein came up with special theory of relativity, according to which speed of light is constant, and that is why gravity cannot propagate instantaneously in space-time and spontaneously in space-time. And another principle of special theory of relativity is law of physics are invariant in all inertial frame of reference. And Einstein also identified that there are many flaws in Newton's gravitational theory. So in 1915, he came up with his general theory of relativity by giving his famous field equation, that is R mu nu minus 1/2 R g mu nu minus lambda g mu nu is equal to 8 pi g over c raised to 4 t mu nu. Einstein used curved geometry or non-Euclidean geometry or Riemannian geometry to explain gravity as deformation of space-time. Earlier, we showed that gravity is not fundamental force or interaction. Rather, it is deformation of space-time. And that is why it is difficult to quantize gravitational force in the framework of quantum field theory. By defining this term as g mu nu, that is Einstein tensor, We know that G mu nu is proportional to T mu nu by considering cosmological constant is equal to 0 for steady state theory. So G mu nu proportional to T mu nu. G mu nu is Einstein tensor and T mu nu is energy momentum tensor, which tells that there is interplay between mass and space-time. Einstein's tensor defines curved space-time, while T mu nu defines mass term in gravity. So there is a reciprocal action according to this interplay, which tells that mass tells spacetime how to curve, spacetime tells mass how to move. This sentence was uttered by John Wheeler, and earlier many times I explained this sentence in my YouTube channel. So there are several predictions in general theory of relativity regarding gravity. First prediction is precession of perihelion of Mercury. We know that in solar system, all planets are rotating around sun in elliptical path. But according to general theory of relativity, this elliptical orbit is also rotating around sun. And there is a precession of perihelion for each planet. Einstein gave precession of perihelion of Mercury, which was exactly same according to mathematical answer. And that is why this was the first successful proof of general theory of relativity. Another thing is, we know that in flat space-time, natural trajectory of object is straight line. While in curved space-time, natural trajectory of object is curved, as heavier mass will create more warping around it. Earlier, I gave one example that if kids are playing in the amusement park and jumping in the rubber membrane, heavier kid will create more warping. So this is how we can have explanation of general theory of relativity. And in curved geometry, natural trajectory of object is also known as geodesic, which means shortest distance in curved space-time. So this was the first proof, that is precession of perihelion of Mercury. Second proof is gravitational lensing. For example, we are receiving electromagnetic waves from distant star which is situated backside of sun. Because of sun's gravitational pull, whatever light we are receiving will be bent near sun. So at Earth, these light seem to be moved in the outward direction, and we will see these stars in zoom format or zoom mode, which is known as gravitational lensing. Here I have explained gravitational lensing in simple words. It is more complex concept that I will cover in separate video. So this was another successful proof of general theory of relativity, and it was observed by famous astronomer and observer, British observer Arthur Eddington during solar eclipse. As in the normal days, because of sunlight, we cannot observe such kind of phenomena. So Arthur Eddington observed gravitational lensing during solar eclipse, and this observation made Einstein star in general relativity and in physics community. So this was the second proof of general theory of relativity. Third prediction was gravitational wave. Einstein predicted existence of gravitational wave. According to this phenomena, there are ripples in space-time because of acceleration of masses. But Einstein believed that as its value is very less, very small, he was doubted that we cannot observe gravitational wave in near future. But in 2015, in LIGO, physicists observed gravitational waves which was produced by two black holes which were away near 1500 million light years, and this was third proof of success of general theory of relativity. Fourth thing is, which is bizarre and interesting, is black hole. According to this object, gravitational pull of gravitational collapse of star or galactic collapse is so intense that even light cannot escape from event horizon. And further, physicists named this object as black hole, as even light cannot escape from the surface, which that we call event horizon. So this is why general theory of relativity is very interesting theory. Many physicists call it very beautiful theory of modern physics, and it is general theory of relativity in nowadays which explains gravitational force completely. Another thing is, it is difficult to unify general theory of relativity in quantum field theory. Why? Earlier I explained that quantum field theory is background dependent, while in general theory of relativity, it creates space-time itself. So it is background independent. So it is difficult to quantize gravitational force with rest of three fundamental force. And thus, there are many proposals of quantum gravity like Regge calculus, causal dynamic triangulation, causal sets, string theory, loop quantum gravity, twistor theory. Among all of them, I explained that string theory and loop quantum gravity are promising. Among these two, I worked in loop quantum gravity, which was originated from general theory of relativity, and that is why it is background independent. So this is what is called gravity, according to this book, as complete explanation of general theory of relativity or gravitation requires to study many books. First, classic books, which was written by John Wheeler, Kip Thorne, and many others, has 1300 pages. So you can understand that it is very difficult to understand gravity with mathematical framework. But in this lecture, I have only covered fundamental results of gravitational theory or general theory of relativity. In the next chapter of this book, that is Loop Quantum Gravity for Everyone, we will see quantum theory. By seeing quantum theory, you are ready to understand how to quantize gravity with quantum field theory at fundamental levels with simple words. Thanks for listening and watching. If you like my video, please share and subscribe my YouTube channel. If you have any question regarding this explanation, you can ask in the comment section. Hello friends, welcome to my channel Physics with Rakshit. We know that we are seeing the book Loop Quantum Gravity for Everyone, authored by Rodolfo Gambini and Jorge Pullin. In two previous videos, we show some fundamentals of quantum gravity and fundamentals of general theory of relativity. In the present video, we will see some fundamentals of quantum theory. And in the fourth lecture, we will enter in the fundamental framework of loop quantum gravity according to book, which is fundamental for all like physicists, amateurs, and those who want to understand what is loop quantum gravity. So we know that earlier Greek philosopher believed that matter is made up of atoms, and some Indian philosophers like Kana, who gave Vaisheshika Darshana, Vaisheshika philosophy, who also believed that matter is made up of Paramanu, which we call atoms. And thereafter, Dalton came up with some chemical reactions that includes atoms and molecules. To understand some electrical and other physical phenomena, afterwards, some physicists came up with various atomic models like plum pudding model given by Thomson, other model given by Rutherford. These Both models were unsuccessful to explain stability of atom and nucleus. Thereafter, various physicists described fundamentals of quantum physics. In the beginning of 20th century, Max Planck gave quantum physics to explain black body radiation curve, and he quantized energy of black body, that is E is equal to hf. Afterwards, Niels Bohr quantized angular momentum of particles which are rotating around nucleus, and various physicists gave atomic model which could explain stability of atoms including nucleus. We know that in nucleus there are neutrons and protons which are also made up of quarks. Around the nucleus, electrons are orbiting in orbits, and subclass of orbits are suborbitals, which are described in atomic physics that I will not discuss here. There are many fundamental laws of atomic physics like Aufbau, Pauli, Hund, and many others that describes atomic physics in quantum manner. And there are some quantum numbers that describes atom successfully by considering quantum traits like principal quantum number, angular momentum, magnetic, etc. that we will not discuss here because of time limitations. Thereafter, physicists came up with various interpretation of quantum mechanics, various ways to understand quantum mechanics. First of all, Schrodinger, Max Born, and many other physicists described wave mechanics, which is one way to understand quantum physics. Thereafter, Heisenberg and other physicists came up to understand wave mechanics with the mathematics of matrix. And Paul Dirac came up with mathematics of operators in operator mechanics. These three are different windows to see the same problem, that is quantum physics. Here, why quantum mechanics is very difficult to understand. In classical mechanics is completely deterministic, continuous, and there is no bizarre traits like quantum mechanics has. Quantum mechanics is probabilistic by nature. It considers superposition. In quantum mechanics, physicists study microscopic particles, and this is the reason why it is very difficult to understand their mechanics. It considers duality. It means sometimes reality behaves as wave, sometimes reality behaves as particle. And that is why de Broglie came up with this theorem regarding duality, which is known as matter waves. We know that quantum mechanics is also uncertain. Heisenberg gave his universal uncertainty principle, according to which position and momentum or energy and time cannot be measured simultaneously. Quantum mechanics also exhibits granularity. It is probabilistic by nature, and that is why physicists like Einstein and Schrodinger in the beginning hate quantum mechanics because of this trait. And there was a disputable debate between Einstein and Niels Bohr regarding the interpretation of quantum mechanics that we know. Another thing is general theory of relativity that studies macroscopic world is also continuous, deterministic, and which doesn't have probability. So it is very difficult to quantize gravity, which is explained by general theory of relativity in quantum mechanics. Thereafter, in 1905, Einstein came up with special theory of relativity, and physicists unify special theory of relativity with quantum physics, and quantum field theory was born. There are three quantum field theories. In the previous video, we saw some basics. In quantum electrodynamics, we study electromagnetic interactions, which is mediated by photon. In quantum chromodynamics, we study strong nuclear force, which is mediated by gluons. In quantum flavor dynamics, we study weak nuclear force, which is mediated by plus or minus W or Z0 boson. By unifying these three quantum field theory, we can have grand unified theory, which cannot unify gravity in this framework because of certain difficulties. Like these three theories are renormalizable as we can get rid of infinities and anomalies which are occurred in the equations. But gravity is non-renormalizable theory in quantum field theory framework, and this is the reason I am describing loop quantum gravity. Loop quantum gravity describes quantization of gravity with novel quantization technique that I will explain soon. In quantum mechanics, there is one bizarre experiment designed by Thomas Young, according to which when electrons are emitted from source, it will pass from one slit. Thereafter, becoming coherent, they will pass from two slits. Here, problem arises. We cannot say whether electrons will pass from this slit or this slit if we consider electrons as particle. But if we consider electrons as wave, we can have pattern, interference pattern on screen because of superposition of waves here. And we can have like this pattern. Here, problem is if I put detector in the path of these electrons, electrons will spontaneously behave as particle and its wave function will be collapsed according to quantum mechanics, particularly Copenhagen interpretation. And that is why, including physicists, quantum mechanics is very difficult to understand, as we cannot say when and where matter or any particles will behave either wave or particle. So quantum mechanics is non-deterministic, and there are many bizarre traits like I explained, probability, granularity, etc. To understand these problems more clearly with some up to some extent determination, Richard Feynman came with his approach, which is known as sum over history. He considered aggregate results of all waves by integration, and he gave this approach sum over history. By this method, we can get rid of infinities up to some extent, and we can study renormalization of these three theories in quantum field theory. We know that in the second video, I explained that gravity is not force, rather it is deformation of space-time. This trait is the biggest hurdle in quantizing gravity in quantum field theory. Earlier, I explained that there is one class of quantum field theory, that is Yang-Mills theory, which studies various quantum field theory like quantum electrodynamics, quantum chromodynamics, quantum fluorodynamics, grand unified theory, in which there are several electric and magnetic fields which are interacting with each other. And to understand loop quantum gravity, you have to understand Yang-Mills theory first. Then you can enter in the realm of loop quantum gravity. To understand quantization of gravity, nowadays there are two promising candidates. First one is string theory, which was originated from quantum field theory, and that is why it considers background dependent. You have to consider prior space-time to understand trajectory of various particles. In string theory, like if you break it any object into small particles, and if you see these small particles, we will have atoms, and in a nucleus we have quarks, which are made up of vibrating filament of energy. In string theory, it is known as one-dimensional strings. Actually, there are many varieties of strings like 0 dimension to 9 dimension. In string theory, it is known as membranes or D-branes. Let us see some interesting facts of string theory. String theory is background dependent as it doesn't consider one of the important symmetry of physics, that is active diffeomorphism invariance. It only considers passive diffeomorphism invariance. Another bizarre traits are to understand string theory, we require some unusual and difficult mathematical concepts like supersymmetry, which is not yet observed. We require 11 dimensions to understand string theory, which we cannot imagine or perceive by naked eye. There are several bunch of particles to understand reality in string theory, and it can explain microscopic as well as macroscopic aspect of reality or nature, but by these cost. But in loop quantum gravity, it is conservative approach. It is background independent. As in general theory of relativity, we describe gravity using geometry. Loop quantum gravity is another name is quantum geometry. Here, what we are doing, we are quantizing geometry of space-time. And Carlo Rovelli, who is one of the father of loop quantum gravity, once told that in loop quantum gravity, loops are one-dimensional objects that form in space, while in string theory, strings are one-dimensional objects that moving in space. So this is the main and key difference between string theory and loop quantum gravity. Similar to string theory, which is originated from quantum field theory. Here, loop quantum gravity is originated from general theory of relativity. So, in loop quantum gravity, we require novel quantization techniques as it doesn't consider classic way of quantization in quantum field theory. It considers usual 4 dimension, and that is why we can perceive and imagine. Here, we don't require some imaginary concept like supersymmetry and extra dimensions. So it is conservative approach, and that is why I worked in loop quantum gravity. Here, space-time will emerge naturally as it studies gravity by studying geometry. Here, one problem is that we cannot understand order of time. Like there is one problem, frozen time, but there is one solution also in loop quantum gravity by considering dynamical framework of loop quantum gravity, which is spin form, which is evolution of spin network. We can have solution of this problem. Similar to quantization of matter, if we quantize matter, we can have atom. If we quantize electromagnetic radiation, we can have photon. If we quantize space, we can have atom of space that I have shown here. I will describe what is atom of space, what is spin network, what is spin form in the 4th video of this series. Up to some extent, according to book, as loop quantum gravity is very complex theory, as I explained earlier in the 1st and 2nd video. So in the present video, we see history of atomic and quantum physics, bizarreness of quantum mechanics, why gravity is not quantized in quantum field theory, discrepancies between string theory and loop quantum gravity, and why we will study loop quantum gravity in this book, that is Loop Quantum Gravity for Everyone. Thanks for listening. If you like my video, please share and subscribe my YouTube channel. If you have any question regarding this lecture, you can ask in the comment section. We will start loop quantum gravity from next video. Hello friends, welcome to my channel Physics with Rakshit. In the present video, we will see 4th chapter of loop quantum gravity for everyone, that is loop quantum gravity, authored by Rodolfo, Gambini and Jorge, Pullin. In first 3 videos of this series, I explained fundamentals of quantum gravity, fundamentals of quantum theory, general theory of relativity according to book. And in the present video, we will see very fundamental of loop quantum gravity, which is enough for people who want to understand what is loop quantum gravity, like other physicists, amateurs, and some laymen. Let us see. Here, I will explain cause of the word loop in loop quantum gravity. Earlier in physics, Faraday tried to explain electric and magnetic field in terms of field lines. It is very interesting that Faraday was not trained systematically in physics, and he worked in one bookstore, and he gave visual tool to imagine electric and magnetic field like this way. Here I have shown electric field lines of positive charge, one wire and bar magnet. Here electric field is outward, and as we go outward further, intensity of electric field decreases. Here electric field of wire is shown where electric field lines are perpendicular to this wire. And here magnetic field of bar magnet is represented where magnetic lines emerges from north pole and emerge in and go in from south pole. Here magnetic field lines make loop while electric field lines cannot make loop. This field line follows Coulomb law, that is F is equal to K Q1 Q2 over R square. It means the more intensity electric field has, the more tightly packed electric field lines it will have. Based on squared distance, F is inversely proportional to squared distance between charges. Earlier we showed that in physics there are four fundamental interactions: electromagnetic force, weak nuclear force, and strong nuclear force. And I explained that in quantum field theory, these three forces are explained by class of quantum field theory, that is Young-Mill theory, in which there are several electric and magnetic fields which are interacting with each other. And thereafter, physicists in loop quantum gravity tried to modify Young-Mill theory to explain quantization of space-time. First of all, in 1980s, Gambini and Trias tried to understand quantization of gravity using modification of Young-Mill theory. Thereafter, in 1960, Ashtaker came up with new variables of classical and quantum gravity, in which he modified Young-Mill theory using one property of field line. Here, strange thing is that in loop quantum gravity, field lines are allowed to intersect, pierce, and puncture, which will create many new concepts in the field of quantum gravity according to mathematics and according to physics of Planck units that I will explain soon. So here, using modified Young-Mill theory, Ashtaker represents general theory of relativity, in which he rewrite geometry of space-time in terms of these several electric and magnetic fields of Young-Mill theory. Here what happens in this represent, field lines are allowed to intersect, pierce, and puncture, as I told, and that is why it will quantize geometry of space-time in loop quantum gravity that we will see. Based on one concept of spin network which was given by Roger Penrose, physicists are trying to quantize geometry of space-time in loop quantum gravity. Let us understand what is a spin network in short way. Roger Penrose wanted to explain geometry of space-time using quantum theory. Basically, he wanted to quantize geometry or wanted to quantize space-time. So first of all, he looked into various quantized quantity, and he found that space-time lines can be represented using angular momentum or quantized angular momentum. He also demonstrated that by this version of quantum gravity, we can have classical geometry as limit, and this representation is known as spin network, in which various spin network lines are there, which are represented by many mathematical tools and many mathematical theory like group theory, etc., that we will see in this video up to some extent in and many separate videos in my YouTube channel. So here, these spin network lines have numbers or colors according to group theory. For instance, here I have shown some versions of spin network. Here, from starting point, if we come again to this point, we will have one loop. So this is the cause of loop behind loop quantum gravity. In physics, there are many concepts which study loop-like concept like Wilson loop, Polyakov loop, that we will study in separate videos. It is very difficult to explain this mathematical concept in such videos. Such videos are intended to normal physicists and amateurs who just want to understand what is loop quantum gravity. I will cover rigorous mathematical concept of loop quantum gravity in many separate videos in my YouTube channel. So here I have shown spin network lines which create various spin networks. These are nodes, these are spin network lines, and these are numbers of spin network lines. Here specific mathematics is there whether this spin network line will have 3, 2 or 1 number. It is not random mathematics. I will cover particular mathematics of spin network and spin network lines and its evolution, how it creates quantization of space-time in loop quantum gravity in many videos. By zooming this node, we can have this diagram where ABC are internal indices of these geometries that I will explain. So in loop quantum gravity, in general, these spin lines create kind of graph. Those who are mathematician and aware with graph theory can understand this. These spin lines will create kind of spin network, which is nothing but kind of graph. And these lines are represented by group states or group theories, which creates loops in loop quantum gravity. And here these loops are allowed to view, and these views will create nodes in loop quantum gravity. So by studying these concepts, node theory is deeply connected with loop quantum gravity. You can understand this, and by this connection, many other concepts were generated in loop quantum gravity and have been generating in this field. Let us see complexity of loop quantum gravity. As many people are amateurs and other physicists and laymen, it is my duty to explain complexity of loop quantum gravity. Loop quantum gravity involves, as it is originated from general theory of relativity, it involves many geometrical concepts, many geometrical theory like topology, global analysis, differential and algebraic geometry, knot theory, group theory, infinite dimensional analysis, functional analysis, non-commutative geometry, etc. So you should keep in mind that it is not that simple that I have been explaining in these videos. So what happens in loop quantum gravity, physicist explains spin network state using wave functions. We know that in quantum mechanics, quantum states are represented by wave functions. In loop quantum gravity, quantum states of spin network states are represented by these functions, which were explained by Rovelli and Smolin. And in loop quantum gravity, thereafter, Astaker and Lewandowski came with one measure, which is known as Astaker-Lewandowski measure, according to which, for instance, here state A and C are identical to each other, as I can deform state A into C. But though A and B are identical to each other, the node of the B state cannot be deformed, and that is why A cannot be deformed into B, or B cannot be deformed into A. And that is why between these two states, A and B, there is an infinite distance. But A and C are close to each other. This concept is explained by Astaker-Lewandowski measure, and thereafter other physicists in loop quantum gravity community gave one principle which is known as lost F, and they explained that this measure is unique and its mathematics is precise. So loop quantum gravity is precise mathematical theory. Its mathematics is not random. Thereafter, physicists tried to quantize various geometrical observables in loop quantum gravity. Earlier, I explained that general theory of relativity explains gravity using geometry, and loop quantum gravity tries to quantize gravity or try to quantize general theory of relativity, which is, and that is why the reason is another name of loop quantum gravity is quantum geometry. So physicists have been trying to quantize various geometrical observables in loop quantum gravity, and physicists have quantized some geometrical observables like area and volume. Let us see what is the physical significance of this concept. In loop quantum gravity, if how many lines of graphs of states pierce any surface, if we know this, we can have quantum of area or area operator. Here I have shown surface acquires a quantum of area by knowing how many lines pierce this surface or how many spin lines pierce this surface. This is how you can have quantum of area. Similar to area operator, if we have knowledge of how many intersections of quantum states have within the region, we can have quantum of volume, which is also known as volume operator. Here I have shown grain of space where graph formed by nodes connected by links. Here these dots are nodes and these lines are spin network lines. In 3 dimensions, it will create quantum of volume. In quantum gravity, as in quantum mechanics, we use concept sum over history given by Feynman to understand probability of all paths covered by particles like electrons and protons that I explained in double slit experiment. Similar to that, in loop quantum gravity, physicists used sum over geometry concept, which is similar to sum over history, to understand probability of various states or transition of spin network states in loop quantum gravity. So here probability of spin network states are explained by sum over geometry concept. Many physicists like Thomas Thiemann in loop quantum gravity successfully quantized Einstein field equation with precise mathematics, which suggests that its mathematics and conceptual clarity is very precise. And now, right now, and from many years, physicists are looking for many physical phenomena in which they can demonstrate concept of loop quantum gravity. And up to some extent, physicists in loop quantum community are successful to demonstrate physical significance in many physical phenomena. So here I have shown puncture of or pierce of surface grain of space, and this is the atom of space. In the previous video, I explained that smallest sub-constituent of matter is atom. Smallest sub-constituent or quantum of electromagnetic radiation is photon. And similar to this smallest sub-constituent of space according to Planck units is atom of space, which is represented by this diagram. Here dots are nodes or vertex lines. These lines are spin network lines. By this way, we can understand loop quantum gravity. Another thing is the fundamental units of loop quantum gravity is Planck units, in which Planck length is of the order of 10 raised to minus 35 meter. Planck area is of the order of 10 raised to minus 70 meter square, and Planck volume is of the order of minus 105 meter cube. So we can have fundamental limits on each geometry, and that is why it is precise. And mathematics of loop quantum gravity is very, very elegant and beautiful, that we will see in many separate videos, as I cannot explain mathematics of loop quantum gravity in these videos. These videos are intended to normal people who want to understand what is loop quantum gravity. That's it. So here in this video, we have shown fundamentals of loop quantum gravity, reason behind loop word in loop quantum gravity, how Faraday demonstrated field lines in electric and magnetic field, how physicists in loop quantum gravity used this concept. They modified one property of field lines. In classical physics or in normal physics, field lines are not allowed to intersect, while in loop quantum gravity, field lines are allowed to intersect. And thereafter, fundamentals of loop quantum gravity were born. Ashtakar came up with his new variables. Physicists gave modified Young-Mills theory. Physicists explained measure in loop quantum gravity, quantum states in loop quantum gravity, quantized Einstein field equation. Another thing is, I will explain soon. Here, there are two ways of quantization in loop quantum gravity: canonical quantization and covariant quantization. In covariant quantization, physicists consider evolution of spin network which generates spin foam using some of our geometry concept. There are many technicalities in mathematics of loop quantum gravity, like Ashtakar variable, metric formulation, connection formulation, Palatini action, ADM formalism, and many others that I couldn't cover here, but I will cover soon in my channels. So here we have shown this whole concept regarding loop quantum gravity. Thanks for listening and watching. If you like my video, please share and subscribe my YouTube channel. If you have any question regarding this video and fundamentals of loop quantum gravity, you can ask in the comment section. From next videos, we will see some future outcomes of loop quantum gravity, further developments in loop quantum gravity, applications of loop quantum gravity. Hello friends, welcome to my channel Physics with Rakshi. In the present video, we will see fifth chapter of the book Loop Quantum Gravity for Everyone, authored by Rodolfo, Gambini and Jorge, Pullin. In this chapter, first of all, we will see some basics of thermodynamics. Thereafter, we will see concept of black hole entropy, Bekenstein entropy, Hawking radiation. Thereafter, we will see black hole thermodynamics. Thereafter, we will see calculation of black hole entropy in loop quantum gravity, how theorist or physicist eliminates singularity in loop quantum gravity. So let us start. In thermodynamics, any system has two kinds of states, microstates and macrostates. For instance, macrostates means overall property like temperature, pressure, volume, etc. Microstate means specific configuration. For instance, if we consider molecular gas, specifically in Avogadro number, there are 10 raised to 23 molecules in that system. So we cannot keep track the actual states of this system. So we have to consider macrostates and microstates in thermodynamics by considering statistical mechanics. So this is the first concept that we require to study quantum gravity. Another thing is entropy. Earlier in my YouTube channel, many times I discussed various definitions of entropy. Entropy, in general, entropy means measurement of randomness or disorder. Another definition is loss of energy to do work is also entropy. And in this context, entropy means measure of ignorance or incomplete information that we have is known as entropy. In closed system of thermodynamics, sometimes we cannot keep track the whole physical process of thermodynamics. So we have measure of ignorance, magnitude of ignorance. The more magnitude of ignorance we have, the more entropy the system exhibits. It is simple, just a simple meaning of entropy in information theory, as we are talking about incomplete information or measure of ignorance. So in thermodynamics, there are three laws. Zeroth law is related to equilibrium. First law is related to conservation of energy. And second law, which is very important, that we require in this discussion of chapter 5, that is application black holes, is entropy either increases or remains constant no matter what you do in physics. So what happens now, by unifying thermodynamics with the physics of black hole, we can have new branch, that is black hole thermodynamics. First of all, what is black hole? We know that black hole is a kind of object whose gravitational pull is so intense that even light cannot escape from the event horizon of black hole. So regions whose gravitational pull so intense that even light cannot escape. For instance, any object which want to go out from the Earth's gravitational pull has to reach escape velocity or escape speed, that is 11.3 kilometer per second. And by this way, various space agencies have been launching various satellites, space shuttles, and various space missions. But in case of black hole, even light cannot escape from event horizon. Its escape velocity is infinite. So we cannot discuss escape speed in case of black hole if any object reaches to event horizon or inside the black hole. So inside black hole, no object can go out. Those objects that reach inside the black hole or up to event horizon. According to Einstein's special theory of relativity, speed of light is constant. So in 1915, Einstein gave is another version of theory of relativity, that is general theory of relativity, to explain gravity and to explain the flaws of Newton's gravitational theory. But here the thing is that even Einstein couldn't understand such kind of weird object that we call black hole in his theory, as it introduced infinity in equation that Einstein called field equations of various gravitational what you call space-time geometries. Thereafter, in 1960s, Schwarzschild came up with first solution of Einstein's field equation, which is known as Schwarzschild metric, in which he considered static point-like object whose whole mass is concentrated on the center with spherical geometry, and that we are calling it black hole. But another thing is that as black hole, even light cannot escape from the event horizon of black hole. How can we observe black hole? This is the intriguing question in physics. So black hole creates effects in their surrounding through which we can observe its presence in space-time. Many black holes get matter dumped on them by a nearby star, and such matter settles quickly via collisions into accretion disk like Saturn has. So black hole's gravity heats up matter and converts into light. And we are observing this light, and by observing this light, we can say that black hole is there at particular region of space-time or particular region of this astrophysical space-time or geometry. Event Horizon Telescope is dedicated to observe black holes' light. And LIGO, that is Laser Interferometer Gravitational Wave Observatory, have been observing gravitational waves which are coming from the collision of various black holes from distant space-time. So how can we characterize black hole? By three properties. There are three properties of black hole: mass, angular momentum, and charge. By studying this property, you can say that whether this black hole is any kind of or other kind of. Another thing is how black hole is created. Black hole is created by stellar or galactic collapse. When any star runs out of its fuel, it shrinks under its arm gravitational pull. In star, we know that outward radiation pressure balances inward gravitational pulls, and that is why star stabilize itself for several million years like our sun. But when nuclear fuel of star is exhausted and star runs out of its fuel, star will be shrunk under its arm gravitational pull, and what happens, it will be converted into various phases of stellar collapse, like initially right from nebula to dust cloud, globule, protostar, brown dwarf star, main sequence, red giant, white dwarf, black dwarf, supernova, neutron star, and black hole. So these are the phases of life cycle of star. Those who are interested to understand these all phases can see my video on life cycle of stars in my YouTube channel. So by this way, we can understand how black hole is created in stellar or galactic collapse. And thereafter, Bekenstein in 80s came up with one analogy in which Bekenstein proposed that black hole's surface area is associated with its entropy. Like in thermodynamics, entropy either increases or remains constant. In black hole thermodynamics, surface area of black hole either increases or remains constant. So I can say that there is a one-one correspondence between surface area of black hole and entropy. And thereafter, another thing is black hole's area is grown when it interacts. As because of interactions, what happens? Black hole will have more randomness or disorder. So it will have more entropy. And by this way, its surface area is grown, and we can say that its entropy also will be grown. So by analogy of thermodynamics, there are three laws of black hole thermodynamics, like zeroth law of black hole thermodynamics, which is associated with surface gravity. Here, there is a one-one correspondence between surface gravity and temperature. Thereafter, first law of black hole thermodynamics, which is analogous to first law of thermodynamics. Second law of black hole thermodynamics, which tells that either black hole's entropy or surface area increases or remains constant. that I have also discussed in one lecture on solution of black hole information paradox in loop quantum gravity in my YouTube channel. Those who are interested can see that video. Thereafter, Stephen Hawking came up with one new proposal regarding black hole. He studied quantum effects outside the geometry of event horizon, and he told that black hole is not totally black, rather it emits radiation which is known as Hawking radiation. He also gave one mathematical relation, that is black hole's temperature is inversely proportional to its mass. It means that if black hole's temperature increases, its mass will be decreased. So we can say that eventually, because of emission of radiation, black hole shrinks, and that is why its mass decreases and it will have more temperature, and ultimately it will be completely evaporated, and that creates information paradox or black hole information paradox, which is one of the unsolved problem in theoretical physics. So here I mentioned that there is a one-one correspondence between surface gravity and temperature, and one-one correspondence between entropy and surface area of black hole. In previous video, we saw that how any surface gains area by piercing various spin network lines or quantum states of spin network lines. We can have area. So we will start with that point. In LQG, a surface acquires area by piercing and spin network lines of quantum states which are corresponding to given space-time, the surface which is in. So in this diagram, I have shown that a given area of horizon can be realized by different spin network pierces through it. As here we are talking about quantum mechanics as well as general theory of relativity, we don't know which exact quantum states of spin network line will give us exact surface area of black hole in loop quantum gravity. We have to consider probability or sum over geometry, like sum over integral of Feynman's approach. So here different quantum states of spin network pierce surface different way, and that is why in the end we have to consider aggregate result to get consistent and tractable results, mathematically tractable results. So when we talk about a horizon of a given area, we don't know which quantum state is given rise to it. So it is the level of ignorance, and it gives us the concept of entropy of black hole. If we can completely keep track the quantum states of black hole in loop quantum gravity calculation, it means that its entropy is completely zero, which is impossible. Whether we are talking about quantum mechanics, whether we are talking about general theory of relativity, whether we are talking about quantum theory of gravity. So the more level of ignorance we have, the more entropy we will exhibit in case of black hole entropy calculation. Thereafter, various theoretical physicists in loop quantum gravity calculated black hole entropy in loop quantum gravity. In previous video, I told that mathematics of loop quantum gravity is consistent, but how to test it? We have to apply this mathematics and physics of loop quantum gravity in established classical concept of physics, whether it is relevant or not. So first theoretical signature we received by black hole entropy calculation in loop quantum gravity. First of all, Carlo Rovelli and Krasnov calculated black hole entropy in loop quantum gravity. Then we will discuss in separate videos that I will cover in my YouTube channels. Thereafter, Ashtakar, Korichi, Krasnov, Baez also came up with calculation of black hole entropy for different kind of black holes. Here, each time these physicists considered different kind of black hole in particular condition for particular limitations. There are some limitation, mathematical limitation also. Here we have to consider sometimes static black hole without black hole without charge and angular momentum. Sometimes we have to consider black hole with charge, sometimes black hole with speed. So there are different cases. Here thing is, in each calculation, there is a presence of one free parameter, which is known as Barbero immersive parameter in calculation of black hole entropy loop quantum gravity, which tells the consistency, mathematical consistency of loop quantum gravity. And those who wanted to know more on the immersive parameter can read my longest review article, which is published in Physics Journal. That is Barbero immersive parameter, enigmatic parameter of loop quantum gravity. In that article, I described immersive parameter deeply with all basics that requires. So there is a one free parameter, that is immersive parameter in calculation of black hole entropy in loop quantum gravity, and it presents in every calculation of these theories. So it tells the consistency of loop quantum gravity. So black hole, we know that in black hole, the whole mass of black hole is concentrated at the center of black hole, which tells that its volume is tends to infinite, and that is why its density tends to its volume is tends to zero, and that is why its density tends to infinite. In classical physics or in general theory of relativity, this problem is occurred as we haven't considered Planck units, which sets cutoff on volume. For instance, in quantum gravity or in Planck units, cutoff value for volume is 10 raised to minus 105 meter cube. So here we are setting cutoff on volume, and that is why black hole cannot exhibit infinite density. And by this way, and mathematics of quantum gravity, which is complex, as I mentioned, we can ignore or we can replace singularity or infinity, which is occurred in black hole calculations. And by Big Bang's model of loop quantum gravity, physicists replace singularity by these models. Here, Big Bang model is replaced by Big Bounce, in which singularity is totally removed by this calculation and Planck units. So elimination of singularity for static black hole is studied where it is replaced by large region curvature through which one can pass into another region of space-time in future. In loop quantum gravity, there are some objects which are theorized, like remnant scenario is one paper in which black hole is converted into white hole through one region or one tube. And another object is Planck star, which is located at singularity point. When black hole makes transition into white hole, it goes via Planck star object. So as I told, as temperature of black hole is inversely proportional to its mass, eventually black hole evaporates, which tells that whatever information is there inside the black hole will be completely lost, which is impossible according to principle of unitarity of quantum mechanics. Actually, from progenitor star, we will get black hole, but during these states, we cannot keep track whole characteristic of progenitor stars. This is what is we call level of ignorance. But after evaporation, whatever is information is there of progenitor of stars, like its spin, mass, angular momentum, dust, and fluids, etc., will be completely lost because black hole is completely evaporated. So it creates black hole information paradox. But here in loop quantum gravity, some theories like remnant scenario, Planck star can avoid and can replace such kind of weirdness from theory by giving consistent mathematical and physical concept that I will discuss in separate videos, and I have already discussed in one of my lecture of doctoral thesis, that is one preprint solution of black hole information paradox in loop quantum gravity. Those who are interested can view my that video in which I have discussed remnant scenario and Planck star with more depth. So what happens? Eventually, black hole evaporates through slow process. We know that here in local frame process, because of time dilation, it requires many years to observe it. So that creates information paradox. Because of principle of unitarity in quantum mechanics, we can say that information is always preserved like energy. So by these theories like remnant scenario and Planck star, we can replace singularity, or we can remove singularity in infinity, which is occurred in black hole physics. So loop quantum gravity is, that is why, very consistent, elegant and beautiful theory which has bright future in quantum theory of gravity. In this diagram, I have shown big bounce model in which, first of all, because of collapse, we will reach here where Planck star is located, and by this region, all mass will go outward and we will have white hole. So this is one cycle. In loop quantum gravity, Big Bang is replaced by Big Bounce model that we will see in next chapter of this book, that is loop quantum cosmology. So in this lecture on application of black hole in loop quantum gravity of chapter loop quantum gravity for everyone, we discussed fundamentals of thermodynamics which is required to study black hole thermodynamics and black hole entropy calculation in loop quantum gravity. Thereafter, we saw some fundamentals of general theory of relativity, some fundamentals of black hole physics, fundamentals of black hole thermodynamics, how in loop quantum gravity physicists calculated entropy of black hole by considering quantization in loop quantum gravity. Various physicists gave calculation for black hole entropy by considering different kind of black holes. Here, this calculation, I want to mention that this calculation is limited for limited property of black holes. Till today, physicists haven't calculated complete black hole physics in loop quantum gravity, as loop quantum gravity is very complex theory. Earlier, I mentioned that in loop quantum gravity, there are many mathematical theory that you have to clear, like topology, global analysis, algebraic geometry, differential geometry, tensor analysis, functional analysis, non-commutative geometry, group theory, node theory, etc. So thereafter, we saw how in loop quantum gravity, singularity is removed by quantization of gravity. And that is why it is also known as quantization of geometry. Thereafter, we saw black hole information paradox, fundamentals, and how loop quantum gravity solves black hole information paradox by giving two theory, remnant scenario and Planck star. Thereafter, we saw fundamentals of big bounce model that we will see in more depth for amateurs, other physicists and laymen in next chapter. Thanks for listening. If you like my video, please share and subscribe my YouTube channel. If you have any question regarding this lecture or any associated concept, you can ask in the comment section. And from next video, we will see another application of loop quantum gravity, that is loop quantum cosmology. Hello friends, welcome to my channel Physics with Rakshit. In the present video, we will see sixth chapter of the book Loop Quantum Gravity for Everyone, authored by Rodolfo, Gambini, and Jorge, Pullin, that is Loop Quantum Cosmology, in which by applying physics and mathematics of loop quantum gravity on cosmos, we can have separate branch that is loop quantum cosmology. We know that when we are talking about universe, we are talking about large scale of the order of galaxy, where our universe is homogeneous as well as isotropic. It means property of universe is same in all points and in all direction. So in LQG, there are certain assumptions on initial conditions so that we can remove Big Bang or singularity by Big Bounce model that we will see. If I extrapolate our universe in the backward direction, we will reach at the point where singularity were there, a point where Big Bang was occurred. And in LQG, there are certain mechanisms, as I told, and certain assumptions on initial conditions so that we can eliminate this singularity. We know earlier I explained that Thomas Thiemann gave quantization or quantized version of Einstein's field equation, using which we can have certain things to say on Big Bounce model that eliminates Big Bang. It is regarding some approximation techniques that removes singularity or Big Bang through Big Bounce model. So in LQZ, physicists of loop quantum community use a Sturcker-Lewandowski measure, which is the robust feature of loop quantum gravity, through which Ojewald, Sturcker, Pawlowski, Singh, and many others gave loop quantum cosmology with approximation to full theory. Here, another striking feature of loop quantum cosmology is there is a minimum limit, certain limit on volume, so that we can eliminate singularity from space-time or quantized space-time, quantum space. We know that in Big Bang, because volume tends to become zero, we can have density becomes infinite. And that is why there were singularity. But what happens in loop quantum gravity, as loop LQG is considering Planck units, there is a fundamental limit on volume, that is 10 raised to minus 105 meter cube, so that we can eliminate volume's value that was zero in Big Bang model. And by this mechanism and using the mathematics of loop quantum gravity, we can eliminate singularity of Big Bang. So here in this diagram, I have shown what is Big Bounce model. Big Bounce model tells cycle of universe. Here, at this point, singularity is there. Initially, what happens after inflation, our universe expanded up to certain point, and thereafter it will again contract in this direction, and it will again re-expand in the past, again recontract in this direction. So this is like one cycle of universe. At this point, singularity is eliminated by mathematics of loop quantum cosmology, and as we are talking about Planck units, here volume is of the order of 10 raised to minus 105 meter cube. Thing is, another question is, can we observe like Big Bounce like phenomena? But I can say that as we cannot reach up to Planck energy, we cannot observe Big Bounce like phenomena. We know that world's biggest laboratory or experimental lab, which is situated near Switzerland-France border, that is Large Hadron Collider, could reach up to 10 raised to 12 electron volt. But when we are talking about big bounce model, it means we are talking about 10 raised to 28 electron volt. It means Planck energy. That is why we cannot observe big bounce model using current experimental features. So at present, we cannot observe big bounce model. But how can we predict that it was occurred? There are certain mathematics, certain assumptions, and certain inferential techniques through which we can say that it may be possible that big bounce was occurred. For instance, in that phase, density of universe was so high that universe were opaque for light. We know that whatever communication that we are doing by means of light, if there is a no light, there is a no electromagnetic wave, we cannot communicate with each other. Whatever signals that we are receiving from distant object are receiving by means of light. In initial phase, our universe was opaque for light, so that it can only observe certain phenomena after our universe becomes transparent to light. So we cannot communicate without light, and after universe cooled off, atoms were formed and universe becomes transparent. We know that how we can receive electromagnetic waves by transition of electrons from one state to another state in orbits. But here we are talking about phase of universe where atoms were not there. And that is why if atoms were not there, how can we receive light? And this was the biggest hurdle to receive any kind of electromagnetic wave that could tell us about initial phases of our universe or evolution of universe. So whatever data that we can say that initially our universe had Planck era where there was no geometry or there was no space-time. After certain development or after evolution, first of all, background was created or geometry was created. It means, first of all, gravitational force was created. Thereafter, we reached to GUT era. It means Grand Unified Theory, Grand Unified Era, where other three fundamental forces were there as one unified force. There were certain kind of symmetry between these three forces, that is electromagnetic force, strong nuclear force, and weak nuclear force. Thereafter, we reached to electronic era. Thereafter, creations of particles began. And thereafter, we reached to era of stellar nucleosynthesis. And from this era, various particles, various like quarks, protons, neutrons were created, and thereafter nuclei, we reached to era of nuclei, where various nuclei were created. And at this era, which we call era of atoms, after which we can receive various electromagnetic waves from distant region of universe, we can observe our universe evolution. And thereafter, we reach to era of galaxies, and this is the present era of our universe, where there are 10 raised to 11 galaxies. And in each galaxy, there are approximately 10 raised to 11 stars. And each star has its own solar system. So what happened, whatever communication or whatever data we are receiving by means of microwave radiation, or it is known as cosmic microwave background radiation. How it was invented, let us see. After cooling off our universe, that light was made transition into another region, that is microwave background radiation, that we are receiving from observatories and satellites which are orbiting around Earth. In 1960s, scientists Penzias and Wilson, who were dealing with noise in microwave antenna, found that these noise were nothing but microwave radiation that they were receiving, and they called it microwave background radiation or cosmic microwave background radiation. For this discovery, they also received a Nobel Prize. As from these cosmic microwave background radiation, we could figure out picture of baby universe or celestial sphere. Yes, actually we cannot show, or I cannot show the actual picture of baby universe in black and white board. But if you Google it, you will see that this picture has many colors. Actually, telescopes receives data in terms of electromagnetic waves, not in terms of visible colors. So how they are decoding these things, let us see. In this picture of baby universe or celestial sphere, different color shows difference in temperature. So by means of coding in colors, we can say that there are certain kind of correlation by means of temperature in cosmic microwave background radiation. How can we say that there are correlation? By observing many times, and by many times many kind of data received by various kind of telescopes, scientists came to conclusion that there are correlation. But according to this data and whatever we have observed till today in cosmology, there are two problems in classic cosmology, that is horizon problem and flatness problem, which tells that initially when Big Bang was occurred, two regions were near to each other. But after Big Bang, these two regions are sharing same property. And according to Einstein's theory of relativity, no object can communicate with speed greater than speed of light. Then how could these two regions had same property? So this is the fundamental problem according to theory of relativity, which was solved by cosmic inflation theory given by Alan Guth and many other physicists. Another problem is flatness problem. Our universe seems flat for us, but actually it is not flat. But whatever data that we are receiving in terms of various cosmological parameters, according to which we can say that our universe is flat. But how can we solve these ambiguities? What Alan Guth proposed here is our universe was expanded with rapid acceleration. And by this mechanism, it may be possible that two regions had opportunity to share same property, and they may have opportunity to communicate with each other with speed equal to speed of light or less than speed of light. So in the beginning, according to fundamentals of cosmology, there were only quantum field. In terms of vacuum, we know that in quantum mechanics, empty space is wrong phenomena. So when we are talking about vacuum, we are talking about quantum fluctuation or 0 point energy. After cooling off, we have reached to the present phase of universe, that is era of galaxy and after era of present universe, and where temperature correlation is there, using which we can study the quantum cosmology and classic cosmology. According to observation in low quantum cosmology, various physicists that belongs to low quantum gravity community told that by means of various assumptions of loop quantum cosmology, loop quantum physics and mathematics of loop quantum gravity. They studied inflation in framework of loop quantum cosmology like physicists Aguilo, Astakar, Barrow, Mena, Almedo, etc. And they came to conclusion that loop quantum cosmology denies need of initial state vacuum in that phase. Why? We know that loop quantum cosmology or loop quantum gravity was originated from general theory of relativity, in which there were no presence of quantum field theory. To quantize theory of relativity or to quantize gravity, we require quantum field theory. So I am talking about that phase where there is no quantum things or no quantum fluctuation according to theoretical predictions of loop quantum cosmology given by these physicists. And they also predicted that there were enough dynamics that can explain why these vacuum states are not needed in inflation theory. There are subtle changes which made imprints as cosmic microwave background radiation in terms of large angular separation. I'm talking about the celestial sphere, using which and by studying these features, we can say that loop quantum cosmology has certain things to tell. By studying experimental limitation, there is not enough chance to observe this all kind of phenomena. But by tweaking these observations according to loop quantum cosmology and assumptions of loop quantum cosmology as per initial conditions, we can say that there is certain similarity between experimental observation and results of loop quantum cosmology, theoretical results of loop quantum cosmology. But here, another limitation is we have not enough experimental data, so we cannot predict more regarding cosmological features of that point using loop quantum cosmology. So another thing is in inflation theory, in classic cosmology, inflatons are field of inflation, and by tweaking the data of inflaton using some initial conditions, loop quantum cosmology predicts exact outcomes as classical cosmology had. So these things are regarding loop quantum cosmology. In this lecture, we have studied how by using fundamentals of cosmology, we can reach to Big Bang model that is replaced by Big Bounce model in loop quantum gravity using fundamentals of loop quantum gravity like Astakar-Lewandowski measure. Thereafter, we show evolution of universe in terms of this data. Thereafter, we show what is cosmic microwave background radiation and how it is important in classic cosmology as well as in loop quantum cosmology, and how various physicists of loop quantum gravity community studies various cosmological phenomena in loop quantum cosmology. Thanks for listening and watching. If you like my video, please share and subscribe my YouTube channel. If you have any question regarding this lecture, you can ask in the comment section. Hello friends, welcome to my channel Physics with Rakshit. In the present video, we will see 7th chapter of the book Loop Quantum Gravity for Everyone, authored by Rodolfo, Gambini and Jorge, Pullin. That is further developments spin form, which is covariant approach to quantize gravity. In the previous video, we showed loop quantum cosmology. Let us start. Earlier, I explained that Thomas Riemann gave quantum version of Einstein field equation, which is quite challenging and which is useful to study dynamics of theory, loop quantum gravity. In loop quantum gravity, there are two kinds of quantization to quantize gravity. First one is canonical, second one is covariant quantization. Canonical quantization is also known as ADM formalism, in which space and time are divided as 3 plus 1. Here we are studying hypersurfaces that I will explain in separate videos in my YouTube channel. Here it is difficult to explain these all concepts in one video for popular audience. In this approach, we use Hamiltonian mechanics. It is also known as Dirac's process of quantization. Second approach is covariant quantization, which is also known as spin form that we are studying here, in which we are considering path integral given by Feynman. In quantum mechanics, when we consider path integral, we are talking about sum over history. When we are talking about loop quantum gravity, it means sum over geometry. Let us see. So it uses Lagrangian mechanics to study quantization of gravity. So as I told it here, we can say sum over history as sum over geometry, as we are considering various trajectory of quantum geometry. We know that another name of loop quantum gravity is quantum geometry. Here, as I told, these lectures are intended for other physicists, amateurs, and those who want to know what is loop quantum gravity. So it is difficult to cover technicalities of covariant approach or spin form, which are covered in the book authored by Rovelli and Vidotto, that is covariant loop quantum gravity. Those who are interested to study this approach deeply can read this book. So here we are studying path integral approach given by Feynman. In quantum mechanics, when we are talking about path integral approach, we are considering various trajectories that are chosen by various particles from initial to final position. When we are talking about path integral approach in loop quantum gravity, we are talking about various trajectories of spin network states from initial to final position, that is sum over geometry. So in this diagram, I have shown how various spin network states goes from one to another states, and we will have various vertices and links. In this diagram, I have shown splitting of one node into two nodes. Earlier, we showed that what is atom of space, in which there are nodes or vertices and links. Here in loop quantum gravity, most famous nodes are trivalent nodes that we will see in separate videos. So by this way, we can demonstrate sum over geometry where spin network states are making transition into another states. Here in some classical equations includes all trajectories that all particles are choosing. These equations also excludes those trajectories that particle will not choose. In this diagram, I have shown trajectories of particles or spin network states, particularly for loop quantum gravity. We are talking about spin network states. Here we have considered three trajectories, that is 1, 2, 3, and which is studied as sum over geometry in covariant loop quantum gravity. Here, similar to quantum mechanics, where we can assign probabilities to various trajectories of particles, here we can also assign probabilities to various spin network states. And thereafter, we can also assign expectation values similar to quantum mechanics. Here, these covariant loop quantum gravity uses various actions, which is nothing but a function of variables of system like Lagrangian action, Hamiltonian action, Einstein-Hilbert action. Those who are studying physics might be aware about this whole kind of action. Here, similar to general theory of relativity, in covariant loop quantum gravity, space and time are at equal footing. And when we are talking about sum over geometry in loop quantum gravity, it means we have considered all spin network states from initial to final point, which is look like form. Here, consider spin network which are made up of fire and submerged into soap water. It will look like spin foam. Another thing is full dynamics of general theory of relativity and loop quantum gravity is challenging. So what we are doing, we are considering quantum gravity and general theory of relativity in 2+1 dimension. It means we are considering two space dimension and one time dimension by ignoring one space dimension. So it is much simpler theory and it is also much fruitful than 3+1 theory. Some results of 2+1 loop quantum gravity are similar to Regge calculus, which was proposed by Ponzano and Regge in 1968. And these results are coincide with this approach, Regge calculus, which is another theory of quantum theory of gravity. So we can say that spin form is quite fruitful as in principle at theoretical level. Another thing is spin form is an example of general class of tensor network which are widely used in condensed matter physics and string theory, and its some conjecture provide bridge between loop quantum gravity and string theory. So we can have some results through which we can study loop quantum gravity with string theory. Both are promising candidates of theory of quantum gravity. In the first video of this series, I mentioned this thing. Thereafter, in this approach, Ority and other physicists of loop quantum gravity community proposed a class of quantum field theory, that is group field theory, which consider Feynman diagram to study elementary particles. And here, results of Feynman diagram are similar to diagram of spin form. We know that Feynman diagram is like graphical representation of scattering theory or scattering process. Those who are studying physics might have heard and might have viewed Feynman diagram that I have mentioned here. For instance, annihilation of electron and positron gives us photon, which in turn gives us quark and anti-quark, and from one of quark we will have gluons. This is one of the representation of Feynman diagram or basic representation of Feynman diagram. So what is path integral approach in context with spin form of or covariant approach of loop quantum gravity? Let us see. Here, as I mentioned, path integral approach studies scattering process. Here, in case of loop quantum gravity, Rovelli and other collaborators are studying final fate of black hole by spin form calculation. And they are predicting the result of final fate of black hole as white hole. These kind of proposals may solve black hole information paradox in loop quantum gravity. It is like time reverse of black hole. But thing is, these calculations are quite preliminary, so we cannot say whether it will give us complete theory or approximation. So this is about what is spin form or covariant approach of loop quantum gravity or dynamics of loop quantum gravity. So in this video, we have shown quantization techniques in loop quantum gravity, how quantized version of Einstein's field equation are useful to quantize gravity in loop quantum gravity. Thereafter, we saw some basics of path integral. Thereafter, we have shown trajectory of spin network states, how it will give us various vortices and leaks according to this diagram. We have also shown this diagram, atom of space. We have shown path integral in context with loop quantum gravity as a sum over geometry. Thereafter, we have shown results in 2+1 dimension and which are coincide with other quantum gravity theories like Regge calculus. Thereafter, we have shown group field theory which is another class of quantum field theory, which study elementary particle in scattering process. Thereafter, we show what is spin form, how it is useful in loop quantum gravity as well as in other branches like condensed matter physics, string theory, and by this result, we can study string theory with loop quantum gravity. Thereafter, we show how various physicists in loop quantum gravity community used spin form calculation to study final fate of black hole. Thanks for listening and watching. If you like my video, please share and subscribe my YouTube channel. If you have any question regarding this chapter, that is further development spin form, you can ask in the comment section. Hello friends, welcome to my channel Physics with Rakshi. In the present video, we will see 8th chapter of the book Loop Quantum Gravity for Everyone, authored by Rodolfo, Gambini and Jorge, Pullin. Name of 8th chapter is Possible Observable Consequences, particularly quantum gravity. Can we measure loop quantum gravity using current technological regime or not, using current experiment or not? That we will see in this lecture. Let us start. We know that unit of quantum gravity is Planck units, in which we consider Planck energy, which is of the order of 10 raised to 28 electron volt. Planck length, which is of the order of 10 raised to minus 35 meter. Planck time, which is of the order of 10 raised to minus 44 second. This whole magnitude will require in the present video. Let us see. In previous videos, we saw that in cosmic microwave background radiation, there are some imprints which tells us regarding evolution of universe. We can have knowledge up to some extent regarding evolution of universe using microwave radiation. And in LQG, we know that in loop quantum gravity, geometrical observables like area and volume are untouched, and which suggests that at quantum level, our space-time is granular. So we have to measure granularity of space-time if we want to see whether we can have observable consequences of quantum gravity or not. So our space-time is granular at micro scale, but it seems non-granular at macro scale. Let us see first kind of experiment in quantum gravity, that is arrival time of gamma ray burst. In school days, we studied dispersion of light using prism, in which white light is separated or dispersed by prism in 7 colors according to their wavelength. So here, among various colors in white light, which travel with different speed, that we call dispersion in that phenomena. We studied such kind of phenomena in ray optics, considering refraction. If we consider electromagnetic light, which is traveling through granular space-time, which can fill dispersion because of granularity of space-time. And if somehow we can measure this kind of dispersion, we can say that we have experimental signature of loop quantum gravity or any kind of quantum gravity theory. So for visible light, this effect is tiny as its wavelength is of the order of 10 raised to minus 5 centimeter. So we cannot have remarkable or measurable effect for visible light, but we can have measurable effect for gamma rays. Let us see. So in 1960s, US set up satellite to monitor nuclear test ban treaty, which observed gamma rays whose source is celestial in outer space, and it is defined as gamma ray burst. Thereafter, in 2017, in LIGO, scientists observed gravitational waves which is associated with gamma ray burst and came from collision of two neutron stars. So here source is far and lambda is shorter as frequency of gamma rays is more. So chances of detection of granularity of space-time is higher in case of gamma ray burst. So both string theory and loop quantum gravity, which are promising candidate of theory of quantum gravity, are looking for such kind of phenomena, though it is yet to be observed. Here, another strange thing is, I have to confess, though I am a physicist, belong to loop quantum gravity community, in loop quantum gravity, here strange asymmetrical quantum states are considered, that is left oblique right, left or right, here to observe such kind of dispersion. Using Compton Gamma Ray Observatory, which is kind of satellite which observes gamma ray burst. So here, by arrival time of this burst in different frequencies, we can have measurement, or we can have experimental signature of granularity of space-time. But it is yet to be observed because of lack of technology, and as we are talking about Planck energy, which is of the order of 10 raised to 28 electron volt, and we have reached in Large Hadron Collider in CERN up to 10 raised to 12 electron volt. But somehow in future, physicists will have this effect as its theoretical concepts are clear. And some physicists suggest that as loop quantum gravity consider left-right asymmetrical quantum states, it rules out whole loop quantum gravity theory. But people who are working in loop quantum gravity suggest that as we have considered only one state, you cannot say that this will rule out whole loop quantum gravity. Physicists are looking for quantum states which are corresponding to such kind of measurement in gamma ray burst, which can give us measurement or experimental signature of granularity of space-time, which will tell us that quantum gravity will be successfully measured in experiment or observed in experiment. So this is first way through which we can have observation. Second way is measuring time and distances. Let us see. In 1958, Wigner and Selecker, who are Nobel laureates, wanted to know possible accuracy of clocks. Here, we know that in atomic clock, we consider two mirrors. Between two mirrors, photons are bouncing back and forth, and its accuracy is of the order of 10 raised to minus 18 second. So this is about some basics of atomic clocks. So here light is bouncing between two mirrors, and every hit to a mirror is considered as a tick in such kind of atomic clocks. So here I have shown schematic diagram of photon which is bouncing between these two mirrors back and forth, and each tick will give us 1 second here. Here clock is in the isolated system, so environment will not affect these clocks ideally. Another thing is, in quantum mechanics, if object interacts with the system, it will be spreaded, as we are talking about probabilistic nature of quantum mechanics. So because of constant bombardment of air molecules on mirrors, such kind of mirror will spread and tick becomes less accurate, and That is why it determines inaccuracy of clock, which is inversely proportional to mass, which suggests that the more massive clock we can make, it means the less inaccurate it is. So in principle, physicists suggest that we cannot make any clock as massive as we wish, as it will be converted into black hole. So Chekenji and Hank Van Dam proposed that we cannot make clocks as massive as we wish, as it will be converted into black hole. We know that, as I mentioned here, Planck time is of the order of 10 raised to minus 44 second, and which is best projected to atomic clock, and it has inaccuracy of the order of 10 raised to minus 18 second. So here inaccuracy is proportional to Planck time. So here factor is of the order of 10 raised to 15. By converting inaccuracy in Planck time into inaccuracy in Planck length by multiplying speed of light, we can have this prediction that measuring time and distances. So here it comes in the range of LIGO, and LIGO, which considers high power electromagnetic wave which has more photon, can measure effect of inaccuracy in principle that was proposed by many physicists. But in experiment, it is observed that here effect of inaccuracies are averaged out, and which was out this possibility. So at present, in LIGO, we cannot measure this kind of inaccuracy, but physicists are looking for more accurate results in LIGO with more sensitivity. And in future, LIGO may have this kind of observation in which inaccuracy in time is converted into inaccuracy in length, and we can have experiment that can give us experimental signature of quantum gravity or quantum gravity. Third proposal is Bell's theorem for temporal order. It considers quantum entanglement. We know that if two or more than two particles are linked or entangled with each other, it means they have shared future. They have shared property. They can communicate with each other with speed greater than speed of light also. And that is why Einstein defined such kind of phenomena as spooky action at a distance. So here, such kind of experiments involves a series of inequalities that entangled systems satisfy, and non-entangled or classical systems don't satisfy. As we are talking about quantum mechanics, here we have to consider probability and superposition. And to define or describe weirdness of quantum mechanics, we know that at that time Schrodinger came up with its cat's paradox, in which one cat is sit in one closed box and radioactive element is connected with Geiger-Müller counter and also connected with poisonous gas. Here there is a probability of radioactive decay 50%, and because of 50% decay, there is a probability of measurement, and that is 50%. If this radioactive element will decay, Geiger-Müller counter will detect it, and at that time, cat will die because of poisonous gas. But before measurement, we cannot say whether cat is alive or dead, and which is weirdness of quantum mechanics, and that is why it is known as Schrodinger's cat paradox. Before measurement, we cannot say reality will behave as either wave or particle, which is known as Copenhagen interpretation. Those who are interested in measurement problem, interpretation of quantum mechanics like Copenhagen interpretation, relational quantum mechanics, hidden variable, many world, and many others. Can see videos on this all interpretation in my YouTube channel. I have given lectures in all these interpretations. So group of physicists thereafter proposed that mass in quantum state where position is not well defined and it leads to entanglement. Here we are considering mass in quantum states and here position is not well defined as because we are considering probabilistic nature. We don't know whether this particle will behave particle or wave. And here we have to consider causality of general theory of relativity in which certain processes are responsible for others while others cannot, which are subjected to constancy of speed of light. And two quantum process in which A influences B and B influences A, where final properties of these quantum states can be tested by seeing Bell's inequality that I have defined here. Those who are interested to see what is Bell's inequality, why it is important, can see videos on Bell inequality in my YouTube channel. I have also delivered some lectures on Bell's inequality and also EPR paradox. So in this kind of tabletop experiment, tiny masses are placed in quantum states where position and mass has a probability of being at distant places could provide fuzzy quantum space-time. As we are talking about superposition similar to wave packet, similar to probabilistic nature as we have considered in double slit experiment where we had kind of pattern here because of position and mass which has probability in quantum states. It can give us fuzzy quantum spacetime which will again give us another proof of quantum theory of gravity or experimental signature of gravity, quantum gravity. Here, another thing is we cannot measure such kind of fuzziness in quantum spacetime is we are talking about Planck units. As I mentioned, at present, we have reached up to 10 raised to 12 electron volt in Large Hadron Collider, which is located at near Switzerland-France border. And we are talking about Planck energy, which is of the order of 10 raised to 28 electron volt. So there is a large difference. And here another thing is, if we consider wave nature, since wavelength is inversely proportional to energy, in that case, to measure Planck length, we have to supply Planck energy, which is impossible in current technological regime. So, in principle, we can have experimental signature of quantum gravity, but because of lack of technological technology and experimental setup, we cannot measure quantum gravitational effect. But there are certain theoretical results which suggest that in future we can measure quantum gravitational effect, particularly for loop quantum gravity, which tells granularity of space-time at quantum level, at Planck level. So in this present video, we saw various experiment or method through which we can have experimental signature of quantum gravity, or particularly for loop quantum gravity. Thanks for listening. If you like my video, please share and subscribe my YouTube channel. If you have any question regarding these three experiments, that is arrival time of gamma ray burst, measuring time and distances, and Bell theorem for temporal order, you can ask in the comment section. And in the last lecture of this series, we will see some conclusions of this book, provided by authors of this book, that is Look Quantum Gravity for Everyone. And in the last lecture, if you have any question regarding whole book, you can ask in the comment section. Hello friends, welcome to my channel Physics with Rakshit. In the present video, we will see last chapter of the book Look Quantum Gravity for Everyone, authored by Rodolfo, Gambini and Jorge. Pullin. It is conclusions of this book given by authors of this book. We know that in previous 8 lectures of this series, we show Introduction to Quantum Theory of Gravity in first lecture. Thereafter, we saw General Theory of Relativity and Quantum Theory up to relevant extent, which is necessary to describe Look Quantum Gravity in second and third chapter. In fourth chapter, we show Look Quantum Gravity, necessary concept of Look Quantum Gravity for audience who want to know what is Look Quantum Gravity. Thereafter, fifth and sixth lecture, we saw application of Look Quantum Gravity, that is black hole and Look Quantum Cosmology. In the seventh lecture, we saw further developments in the Look Quantum Gravity community, that is covariant Look Quantum Gravity or spin form approach. In the eighth chapter of the book, we saw some possible observable consequences of Look Quantum Gravity. In the present video, we will see conclusions. First of all, author gives us that what is Look Quantum Gravity in essence. Look Quantum Gravity is the combination of mixture of Faraday lines. We know that in Look Quantum Gravity, Faraday lines are allowed to intersect and pierce. Second concept is spin network of Penrose that I have described. And third, symmetry is diffeomorphism invariance, which makes theory background independent. Thereafter, author emphasized that don't read online blogs and articles which are written by prejudiced people without technicality and mathematics. And authors also suggest some technical research papers and review papers to read so that people can understand criticism of Look Quantum Gravity and answers given by physicists of Look Quantum Gravity community. There are some criticisms on Look Quantum Gravity here. As a frank physicist and transparent physicist who consider transparency in scientific research and methodology, they give some criticisms of Look Quantum Gravity also with some answers. So first criticism is regarding distance. We know that in Look Quantum Gravity, we consider Astakar-Lewandowski distance, which is important concept. This kind of distance is not considered in rest of quantum theories like quantum electrodynamics, quantum chromodynamics, quantum flavor dynamics, or in short, quantum field theory. They consider traditional distance in quantum field theory. But in Look Quantum Gravity, traditional distance is failed to deliver more tractable ideas in quantum gravity theories. So, this distance differs from other quantum theories which consider traditional distance, and here traditional distance are failed in Look Quantum Gravity. So, this kind of distance was built with diffeomorphism invariance symmetry that other theory don't have. Diffeomorphism invariance symmetry is the core idea of Look Quantum Gravity that makes Look Quantum Gravity background independent. And that is why Carlo Rovelli once told that in Look Quantum Gravity, loops are one-dimensional object that forming space. Rather, in string theory, strings are one-dimensional object that moving in space. So this is the fundamental difference regarding this criticism. Second criticism is emergence of discrete structures in Look Quantum Gravity. We know that in special as well as general theory of relativity and in all quantum field theories, they consider Lorentz invariance regarding relative velocity. But because of discrete structures in Look Quantum Gravity, it may violate Lorentz invariance according to some criticism. Let us see. So LQG's discrete structure may conflict with high precision experiments of particle physics, which consider Lorentz invariance. And this symmetry is proved in experiments with high precision. In physics, as I told, Lorentz invariance present in all three interactions, that is electromagnetic, strong, weak, strong nuclear and weak nuclear interactions, that relates how two observers moving with respect to each other and perceives physics. Including these three, it is also present in general and special theory of relativity at local level. It means we are talking about local symmetry at small region or small distance. And this kind of symmetry has been tested with high precision. While discrete structure has potential to break this symmetry, we are talking about loop quantum gravity, whose intrinsic nature is continuous, as relative velocity of two observers is a continuous variable. Those who are interested to read these criticism can see my one video regarding length contraction and loop quantum gravity. Here, physicists of loop quantum gravity community have solution of this kind of criticism. They can get rid of this kind of result by some mathematical and technical concept that I have addressed in that video. Also, I will address more on loop quantum gravity with more mathematics and more technicalities in other series of videos. Third criticism is that criticizers tells that Riemann theory doesn't capture dynamics of general theory of relativity. We cannot emerge dynamics of general theory of relativity out of loop quantum gravity, according to criticizers. Let us see. But physicists of community prove that it can have dynamics, it can capture dynamics of general theory of relativity by its novel concept, more mathematical concept, which are validated, and more technicalities. Though there is no definitive proof because of gap between theory and experiment, and also it is complex. Theoretical formalism of loop quantum gravity is more complex. First thing, and second thing is, we know that loop quantum gravity's units are Planck units. So if you want to prove loop quantum gravity in experiments, you have to apply energy of the order of Planck energy, which is impossible right now, as in Large Hadron Collider of CERN laboratory, which is biggest laboratory on Earth, has reached up to 10 raised to 12 electron volt. So we cannot prove loop quantum gravity using current experimental technologies. So this criticism cannot be perfectly addressed because of technical and technological or lack of technology. Another thing is, once Abdul Salam was asked regarding quantum theory of gravity that in theories there is no experimental prediction regarding quantum theory of gravity. And Abdul Salam was theoretical physicist. He answered that, how do you know that a theory doesn't have experimental prediction when you don't have theory? It means, first of all, you have to make a theory regarding quantum theory of gravity. Thereafter, you can predict experiment regarding quantum gravity. So this is the address given by this physicist. Thereafter, author tells that our universe is made up of 73% dark energy, 23% dark matter, and 4% visible matter. We only know 4% matter, though science has been progressing since the beginning of study of science. We could only know 4% structure of universe. Loop quantum gravity, after some times, after few decades, may have answer regarding dark energy and dark matter. And few physicists have been working on these kind of concepts. Our universe is made up of 0.5% stars in this diagram pie chart and 0.3% neutrino and 0.03% heavy elements. So we don't have enough knowledge regarding this 2% or these two category. So in future, physicists of low quantum gravity community may give answers regarding these mysteries of universe using the framework of low quantum gravity. So we don't understand 96% of universe. It means though we have progressed much in science and in physics, we only know 4% of universe. So LQG may answer these all questions and all unsolved mysteries of universe. So in the present video, I complete this lecture series on low quantum gravity for everyone.